There we go. All right. Well, welcome, everybody. Welcome. It is 2 hours UTC, and it's time again for Astronomy Daily Live. And we're all very excited tonight. Some of us are more excited than others. So, yeah. Well, it is an exciting day. This is a day that happens once a year. It is 12/12, right? Now, that's, of course, UTC time, right? So it's 2:01 UTC right now on December 12th, 2018. So yeah, most of you were probably around for 12/12/12, right? So that was pretty cool. But after 12/12/12, that doesn't happen again. Let's see. I guess that's not going to happen again for another 100 years, right? So in 2112, it'll essentially be 12/12/12. But yeah, I guess that happens every 100 years, right? And let's see, there's a 111 and a 222 and a 333. But yeah, you know, there's no 21, 21, 21. So yeah, I guess after 12, it's done. Anyway, that's a tangent for sure. So cheers, everybody. Welcome. Come on in. Come on in to the virtual porch here, where we gather together each and every day, pretty much every day, and you know, pretty much forget about everything else and think and talk astronomical things and sciencey things and that kind of stuff. And we have our favorite consumables right nearby. I've got mine. This is well, I have a favorite consumable, but it sort of comes in a couple of different forms, right? So this I would call 1B. So this is the hydrogen hydroxide, HOH. There's also the dihydrogen monoxide, which you know, is a rare treat. So you know, if I need, you know, extra oomph, I'll do that. But it's normally the HOH, so we've got some nice balance there, and I definitely like balance. So on the panel once again is Bobby. Hey, what's going on, Bobby?
Nothing much here. Just the same old.
So I'm looking in the chat. I noticed that Space TV popped in a little bit early. I saw Tim. He is in there I'm a little bit early too. Elliot, I'm no longer going to call you by your last name, unless you want me to.
And Elliot, if you was looking at the Discord, he directed me to his own website, and I think that was a cool website to take a look at.
Yeah, I saw that.
If you can like post the link in the chat, maybe Cosmo would take a look at it.
Yeah, I took a look at it, and extremely awesome. But Elliot, if it's okay with you, I will call you Chris. Is that all right? Because that, I believe, is your actual first name. So yeah, cool. Yeah, you know, my first name is Matt, but you can call me Cosmic. That's perfectly fine. You can call me whatever you want. We're informal here. But yeah. So I'm glad to see you again in the chat. I was just talking to Bobby before we came on that I was watching P&K space imaging, and you know, I've been a subscriber to P&K, and there's a couple others. I forget the names at the moment. And you know, I mean, all right, I can be extremely dense. In fact, I usually am. But So for several weeks or months, maybe, I've been yeah, there we go. I've been thinking about this, and it's like, why would people just want to spend hours, right, just looking at the moon, right? Now, I greatly appreciate the moon, right? I think the moon is extremely cool. I think it's great to look at, but I was confused as to why anybody would do that. And it finally dawned on me a couple days ago. You know, like I said, I'm slow, right? But it finally dawned on me that there's sort of two things going on. There are people who like to come in and look for these anomalies, as they call them. I would call them transient events, right? But you know, whatever you want to call them, it's fine. But it's kind of it's almost like a citizen science kind of a thing, where you have a bunch of participants, right, and they're all looking at the same thing at the same time. And if you get, you know, 50 or 60 or 70 pairs of eyeballs on the same object at the same time, it's very, very likely that you're going to see something. And I think that is very, very cool, right? That is a clever way of people, well, putting people, you know, sort of voluntarily to work to look for, you know, transient events. Now, what's a transient event, right? What's an anomaly? I sort of distinguish those two, but yeah, I guess, you know, there's not that much of a difference. I would call an anomaly something that you know, sort of isn't supposed to be there. It's like, there's something wrong with the picture, right? And an anomaly could be a transient object. I just sort of categorize a transient objects as sort of being a superset of the anomalies. But transient objects could be like flashes on the moon, probably caused by impacts, right? In fact, these are observed all the time. There's a NASA effort. There's an ESA effort. There may be others, and there's this effort too. And they try to timestamp these anomalies too. So I think it's very, very cool. But the other thing is that it looks like it's a really, really cool community, right? I've been hanging out in the chat for, I don't know, a few times now, and it's a really, really, really great group of people. So I think that's awesome. I think that's absolutely fantastic. So cheers to P&K Space Imaging and all the others. If somebody in the chat wants to shout out anybody there, please do, because deep respect. They've got some good equipment, and it's I guess maybe after a little while it becomes sort of routine, but it's no small effort to do that. Plus, doing it for so long. So pretty impressive. All right, well, I hope everybody's doing well out there. I don't think I heard any don't recall hearing any extraordinary astronomical news today. We talked about yesterday that they think that they found water on Bennu, right? So that's kind of interesting. I guess, you know, they never seem to, well, at least the report I saw. I don't know if they actually ever said water per se. They're talking about hydroxyls, right? Molecules that have hydrogen and oxygen in them. But I don't know if they come out and actually say, you know, water, you know, we actually found it. But, you know, they've only been there a couple days. So, you know, give them a chance. They're going to be there for, I think, at least a couple of years. Yeah, I heard about the spacewalk to investigate that hole. Any interesting news there? Yeah, I think this is the drill hole. Yeah. It's kind of a curious thing. So don't know what to make of that. I don't. I mean, I'm. You know, one hopes, right? One hopes that it's just some kind of a mistake. Is that Blackie again?
Yes, sir.
Hey there, Blackie. He's found a nice seat right there.
Yep.
Cool. All right. Well, cool. Yes. Yeah. So was that? I can't imagine that was the only reason why they did a spacewalk. It was probably part of a thing, right? But maybe that was the only purpose. That'd be pretty amazing. Are there still 6 people up there, or did 3 of them come back yet? Does anybody know? Does anybody know that one? I don't know.
I don't know. Not me on that.
Let's see. All right. Well, cool. Let's. I was over on archive.org looking at the latest papers, but I'm sort of thinking that I don't know. Maybe we should dive into a constellation again. I think we should do that. Just as a reminder too, there is a comet out, and it looks like it's getting pretty bright. I haven't heard or seen any of the latest news. I wonder. Let me see if I can find a site here. You can watch me look. 46p.
Gonna try to find it without slowing down this computer or freezing it up.
Yes, that is the trick. Okay, here's a current status. Okay. Well, here we go. I will share this. I think I shared.
I did tell you about yesterday about Voyager 2 is down in interstellar space, right?
Yeah, I guess there's some indication that it went through some kind of a change. So yeah, you know, it's hard to I don't know if anybody's really defined you know, where the solar system ends and where it begins, and where space begins and where space ends, because technically, I think anything inside of the heliopause is technically speaking, in the atmosphere of the sun. So, and the heliopause is way out there, way out there. So, I think it's a matter of perspective on that. But regardless, you know, Voyager has has been going now for like 41 years, and it's way out there. It's way, way, way out there. I want to say that is New Horizons gonna pass the Voyager and Pioneer spacecraft? I mean, you know, radially. I mean, they're not actually going to, you know, like you know, one is going to zoom by, right? Voyager might be going this way, and New Horizons that way. But in terms of distance from the sun, I don't know if anybody, if any spacecraft are actually gonna exceed this distance of Voyager anytime soon. Voyager's moving fast. Voyager's moving really, really fast. New Horizons might be moving faster though, so they just have to be moving faster, right? And eventually they'll catch.
Maybe you can explain to us what is a heliosphere to Tim Robinson and anybody that probably don't know about the sun atmosphere.
The heliosphere. Let me share my screen. I wanted to show off the comet
and Boshock, according to Chris.
Yeah. It's sort of the outer edge. Oh, I'm going to hide that. It's sort of the outer edge. I'm going to do this. Solar heliosphere. Solar heliosphere. So let's look at this first. So these are the V magnitudes. V, I guess, can stand for visual. It's sort of in the middle of the visual range for us. So I think that's around like 5,500 angstroms or so. So the V magnitude continues. See, you know, this blue line is the prediction, right? Or at least one prediction. And it's still all the observations, right? I guess these are all observations, are falling a little bit under that. And there's a pretty big spread too, right? I mean, this is, you know, from top to bottom, that's about 2 magnitudes or so. But it's looking like the brightest, wow, is actually getting pretty close to 3rd magnitude. So, wow, yeah, that's pretty cool, pretty impressive. So definitely, if you get a chance, getting close to 3rd magnitude with a pair of binoculars, you're going to pretty much be able to see that anywhere. If you want to see it naked eye, you're still going to have to get out relatively dark because it is an extended object. It's a very, very large object. I think it's at least the apparent size of the moon, at least. So, oh, and let me know if this background music is too loud or too soft or anything else. It's just playing in the background here. So this is just one of the episodes from Music from the Hearts of Space. I think it's episode 1188. And at the time, I was recording the intro and the outro sort of dialogue. So at some point here, you're gonna start hearing somebody else talking, and I'll try to turn it down at that point because no one shall do that. So there we go. It's getting nice and bright. I don't know if this is any kind of official light curve or anything. UMD, University of Maryland. So yeah, I don't know how official that is. Closest approach though is coming up in a few days, and then okay. So I guess perihelion is happening first, right? So that's happening right before perigee. So perihelion is the closest approach to the sun, and perigee is closest approach to the Earth. So the reason why this comet appears so bright is a combination of those two factors, right? And the fact, that it's active, of course. So yeah, being so close to the sun, it's about at its brightest it's going to be in this orbit, and the fact that it is as close to the Earth as it's going to get, combination of those two things make it a bright comet. So, and that's not incredibly bright, but yeah, it's bright enough for sure. So yeah, the heliosphere.
Before you continue.
All right, I will do that. I will check the chat. Okay, cool. Thanks, Tim. Yeah, it never will in December. So, yeah, well,
it sucks for you, Chris. I'm not sure what the weather's going to be for around here.
Yeah, well, for sure, if you get the chance, do it because it's especially if you've never seen a comet, this will be a good example for you. You'll remember it for years and years and years to come. So here's sort of the idea, right? Is that the solar system is way in here, right? And they have a bunch of names, right? But the basic idea is that there's some kind of a distinguishing line. I don't know if it's like, density. I don't know if it's a certain temperature. I don't know if it is some kind of, material that they're not seeing anymore, but it's this edge, and this edge actually extends way out there, way to the left, right? Extremely way over there. At least I would say a light year, right? So way over there. But it is a structure that is associated with the solar system.
Now, what exists in the interstellar space?
Well, the idea is that it's very thin, just gas and dust. Probably, most likely, plasma in sort of a non-excited state. But yeah, and that's what's called the interstellar medium. And the interstellar medium is studied very intensely because there is stuff between the stars, and it's a measurable amount, and that causes a lot of things, right? I mean, it's just like dust here on Earth. It can actually redden the colors of things. So something, some kind of object, if that light goes through a thicker part of the interstellar medium, then there's a possibility that the higher frequency light, the bluer light, is going to be scattered, and the red light is going to be able to pass. And so by the time we see it, it actually looks red. And we can measure that amount of reddening. And that actually, in some cases, can help us estimate the distances to objects. That's actually one of the ways to do that, is to measure the amount of reddening. And if you know how much stuff there is, what kind of density there is between you and that object, and you measure the amount of reddening, you can actually calculate the distance to that object. So it's a way of doing it. Anyway, so that's what that is. And yeah, they've actually drawn a little diagram here showing where Voyager 1 and Voyager 2 are. I can't say that this is any kind of correct geometry. The scale, the scale is completely wrong. Voyager here is about as big as the solar system. So, yeah,
Now, if assuming that these spacecrafts are going to be still going to be alive, how long is it going to be until they leave the galaxy?
I think they reach well, I don't think that they are necessarily aimed anywhere in particular, but I think to reach the distance to the closest star, which is about 4 light years away, it's going to take 40,000 years. So that's to the nearest star to us. Now, these guys aren't going anywhere near those stars at all. I'm just talking about distances. So in order to get out of the galaxy, well, we're about, 30, maybe about 10 or 20,000 light years from the edge of the galaxy. So, yeah, just a rough calculation, if it takes 10,000 years per light year, then that's going to be about 10 to 20, no, 100 to 200 million years. So, yeah, short path out of the galaxy for Voyager 1 and 2, a couple 100 million years. So, make your plans now. Now, I should also say, just as a reminder, that Voyager 1 and Voyager 2 are near the end of their life right now. They're running on nuclear energy, but that source is going away, right? So most of the instrumentation is turned off. They have a couple instruments still running, hence the measurements here. I'm gonna stop sharing, I guess. Yeah, I think I'm sort of thinking that I want to say like 2030 or so is when they sort of expect to last here from the Voyager spacecraft. They've already lost communication with Pioneer. Pioneer was first. There's Pioneer, I think it was Pioneer 1 and 2. I don't remember what the numbers were there.
Hey, Tom, what's up?
Is Tom in the chat?
Yeah.
Yeah, cool. Hey, everybody. Yeah, real life will do that. Cheers to real life.
So, Tom, care to join us, or you're going to be like super busy?
Yeah. Speaking of which, if anybody is interested in being on the panel, I think that adds a lot of nice things to this live stream. So if you're interested in doing that, you can send me an email, cosmiclettuce@gmail.com, and just ask to be put on the panel. And what that does for me, right, is it turns on a switch, right? So if your switch is on, then every single day, or each time I live stream, I will send you an email with the link to the Hangout, and I will continue to do that until you tell me to turn it off. And then you're more than welcome to join or not join. We're extremely fun and casual here. It's just like sitting out on the porch, right? If you'd much rather, uh, uh, you know, not be sitting down, you don't want to hover around a little bit, that is perfectly cool. But I am definitely sat down chilling. Yeah, Tim, it's what, 2:31 there in the morning. So
Yeah,
it's
but
either
she got out. But Dizzy Sue, which is Tim's wife,
uh
got out of bed, still in some serious pain. Might have to go to the hospital.
sorry about that, Tim. Yeah, pain. You know, I wish that pain was sort of like some seatbelt things, right? When you get into your car and you don't put a seatbelt on, say, it dings a little bell, right? Ding. And then a minute later, ding, right? So why can't they do that with pain, right? Now, pain means that there's something wrong, right? There's something going wrong, right? So
And it's
I'm not
probably
saying,
a bit weird. The doctors can't find what's going on with his wife and stuff, and which I think that's
uh,
really a bit crazy.
yeah, yeah. But, pain is a good thing, right? I mean, it's a feedback thing because it's telling you, that something's wrong. But the problem is, right, is that you don't need a constant reminder of that, right? It's like, you know, once in a while, maybe once every hour or so, I'd like to, get some kind of little, you know, bell going off saying, something wrong with your leg or something wrong with your head, right? Why does it have to be so incredibly intense and so incredibly constant? So, yeah, I don't know. It's these things that we just inherit, right? So, all right, well, cheers. All right, let's do a constellation of the day. We haven't done a constellation in a while. Most of the time, constellations take us a few days to get through because there's just so much, right? And I mean, really, we could spend months or years on just all the objects in a single constellation. It just goes on and on and on. So I'm going to check my weather again here, just because I'm in the chat. I noticed that I was more humid than you were, Bobby. Yeah, see, I'm at 74 and 46 degrees Fahrenheit. So yeah, that's still pretty humid. I guess it's supposed to be drying out. So I'm glad. I'm glad about that. All right, let's do a constellation of the day. What I've got, I'm going to pull this up. I'm going to pull this up here. Let's see, what screen do I use for that? I think I'll use this one. Okay, so I'm going to maximize that. And then we'll go over here, and we'll go here, and we'll go here. Okay. All right, so I've got this all set up. I'm going to share my screen. Maybe. There we go. So sharing my screen again. I'm going to hide that. I'm going to go over here. So here's a list. You can see it along the left there. This is, and I'm not quite sure why there's a 7 there. Anyway, this is a list of all 88 constellations that are accepted by the
Now,
International.
with those weather games, is it true that the lowest percentage of humidity wins?
The lowest percent what?
The lowest percentage of humidity is the winner, right?
Well, I don't know if there's any winner or loser. I like to compare. So okay, all right. Well, we're we're pretty close to the same thing right now. So wow, that's kind of cool. I like that. Yeah, I don't think. Uh, yeah, I think winning or losing. I think that's a matter of perspective. So hey, Suzanne, feel better. Feel better. Yeah, do what you can. All right. So here's the list, and there's 88 of these. I think we calculated, or I think it was Tom who mentioned that what like 32% of the constellations are in the northern hemisphere, and uh, what would that be? 68%. 68% are in the south, something like that. I forget exactly what the percentage is. So when we randomly choose these, there's uh, it's more likely that we're going to find a southern constellation. But you know, if you live in the south, good. If you live in the north, it's also all right because I mean, really, the constellation is just sort of the the platform on which stands everything else, right? All the stars, all the galaxies, all the other things going on in that constellation. But so let's have Nightbot do something useful and give us our constellation of the day. I think if I do that, is that? I think that's what I called it. Let's find out. I don't remember what I called it, what the command was. Oh, there it is. Okay, constellation number 28. Okay, so I'm going to go down here to number 28. It's Corvus. Well, Corvus is that can pretty much be seen in the north. I guess technically it's southern hemisphere constellation, but let's go over and take a look here at Corvus constellation. Corvus. And what I like to do.
Tell Dizzy Sue, hey.
I did.
I think Tim, I think he probably like missed that.
That's okay. Yeah, I hope you're feeling better soon. So actually, what I like to do first, I'm going to go back because I'm old school, right? So I like to grab my my Burnham's Celestial Handbooks, which are just extremely easily accessible right here in my incredibly profound and organized way of doing things. Just thrown onto the floor and spread out, so I could see it all. So so Burnham's Celestial Handbook is actually three volumes, and they're organized in alphabetical order with the constellations. So Corvus, I think, is in volume 1. So I'm gonna grab volume 1. All right, here we go. Grabbing volume 1. Is this volume 1? I think it is. This is the one that that has a cover. It's just not on it. So yeah, you know, these books are they're let's see, 80, 90. Wow. So these books are almost 40 years old. I've almost had these books for 40 years. Wow. How'd that happen? But they're really, really great. As you can see, they're you know, nice volumes here. And this goes, oh, okay. So this one goes from Andromeda through Cetus. But we're looking for Corvus, CO, so I guess it's in the next one.
Volume 2.
Which one is that? Is this it? Nope, that's volume 3. Here's volume 2. Now, volume 2 has a back cover, and it's got a side, but it doesn't have a front cover, and it doesn't have a front page, and it starts on the preface. And do you see this here? Okay, this is really if I see somebody doing this, you know, I don't know if you've ever seen cats fly before, but I have. So this is kitty stuff. Look at that. Oh man, somebody's in big trouble. Anyway,
somebody pay for that, and I don't know who.
Somebody is gonna pay. That's all I can say. You're right, Bobby. Somebody's gonna pay. So we're gonna look for Corvus here. I don't even know if it's in here. I don't know if I've ever looked. Oh, yeah, it is. Okay, cool. So Corvus is a pretty small constellation, right? Pretty small. But oh yeah. But it has a very, 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 very famous pair of galaxies. Yes. So we'll get to that in a minute. So I really like Burnhams because they provide a lot of information, a ton of information. What they do is they start by listing, at least at the time, was all the currently known binary and multiple star systems. So that's all these here, right? Then they list all the they list all the variable stars, at least the known ones. At the time, I'll bet you there's more now. I bet you there's many more now. And then they also list all of the known non-stellar objects, right? So all the clusters and the galaxies.
And Tom Van Score says like Gorilla Tape would be able to fix that.
Yeah, I'm gonna have to pull out. I'm gonna have to pull out the astronomers and the engineers' best friend in the world, and that is either Gorilla Tape or duct tape. Right? Duct tape will fix this, no problem. No problem. It'll last another 40 years, 40,000 years, right? They probably used duct tape with Voyager, and that's why it's lasting as long as it is. So, but then what Burnham's does, and this is sort of a poor example, you know, because the constellation is small, there's not a lot of interesting things, but they sort of briefly describe some of the brighter stars, right? Some of the brighter stars, and they also talk about some of the non-stellar objects, right? The NGC objects. Let's see, do they do anything else? Well, that's about it. That's about it. So it's kind of interesting. We're going to have to look at the chart, but usually in the naming conventions with constellations are such that the brightest object is named Alpha, right? And then the next one, oh, there's our other speaker. So I'm going to go back. There we go. That'll last us the rest of the live stream. Cool. like I said, normal naming conventions would be, the brightest star is alpha, and then the next one is beta, and the next one is gamma. It sort of follows the Greek alphabet, right? And that has some kind of historical reason I don't remember. But strangely enough, I don't see any alpha here. It starts with beta. So what's going on there? I'm not quite sure. But they give a little bit of information, what they know about these stars. Now, oftentimes, Burnhams will also talk about variable stars or binary stars or anything. But I guess these aren't particularly too interesting in any kind of way. But we'll dive a little bit more into this constellation, because there's always more. There's always more. So I guess probably what we should do is look at this famous galaxy, and I guess they're calling this one object. I always thought it was two, but I guess that isn't correct. It's NGC 4038, and they have some photographs of it. So you who have seen this object before know that this is the famous ringtail galaxy. So yeah, these are, I guess how the story goes is that these are two galaxies that are colliding, interacting in some way, and yeah, causing quite a bit of excitement.
Tim,
what's that?
check the chat.
Okay. Is Tim on his way out? Oh, okay. All right. Well, take care, Tim, and I will see you later. Thanks for coming in. Thanks for coming in. So yeah, I think what we should probably do is start right here and go to HST and see if we can find a better a better image of the ringtail galaxy. And in fact, I guarantee that if you Google that, you will find some extraordinary images. What I like to do is I like to go to sort of the data source, right? So go to the Hubble Space Telescope, go to their image section, look at the raw images. Now, if we want to do anything with these raw images, colorize them, or zoom in on them, whatever we want to do, then we can do that. I like to take sort of the raw information and mess around with it instead of letting somebody else do it. So yeah, why don't we start there? So NGC 4038. I'm going to let's see. Okay, well, yeah, let's do that first, and then we'll come back. We're really easy and casual here, so there is no set way of doing this. So let's do this and see if HST has imaged it. If it hasn't, I will be extremely surprised. So 4038. Isn't that it? 4038? Yeah. Bam. I'm certain that this has been looked at, yeah, quite a bit. So we'll sort this by time so we can sort of see the latest and greatest. Looks like somebody looked at it in 2017, but that image isn't available yet. That's all right.
Why are you not sharing your screen?
Oh, I'm not sharing my screen?
No.
Well, that's not very nice. I should be doing that. There, now I am. Thanks, Bobby. Okay, here we are. So you see, this first one isn't available yet. Most HST data and sort of scientific data in general isn't sort of publicly available until maybe 6 months to a year after it's acquired. Now, that's not always the case, but I think in the case of HST, it is. And I think that, I don't have a problem with that. These people, who have written a proposal to get time on this scope, right? They have a plan. They know exactly what they want to look at. They do all the work, right? So as far as I'm concerned, they definitely deserve first dibs, right? And I mean, that's what it comes down to. So let them do their thing with their data, right? Whatever it is, right? My only request is that at some point, right? I mean, as soon as they can, make it publicly available. And HST does that. And in fact, most federally funded and even privately funded work most definitely is publicly available, which I think is great, because that makes what we're doing here like so incredibly cool, right? Because we can look at this data from the virtual porch. It's absolutely amazing. So here we are. I'm not quite sure what they're looking at here. Kind of hard to tell. It's a very, very, very short exposure, right? 20-second exposure. Let's see. Central wavelength, 4325 angstroms. We can actually look at a little bit of the details of the what these folks are wanting this time for. I guess they're looking at supernovae recently as precise cosmological probes, resulting in the Nobel-recognized discovery of the accelerating universe. Yet, even with over 5,900 known supernovae, we know relatively little about the stars which give rise to these powerful explosions. So yeah, it's like, which star is going to pop next? We don't know. That's going to change once systems like the LSST are running. We're actually going to be able to hopefully see some of these progenitors, before they explode, and that's going to be really, really nice. So it sort of looks like what they're doing here, right? I'm presuming a little bit, but it's sort of looking like they're taking images, hoping that somewhere in here is a progenitor star that is going to explode. And I think they probably purposely chose this galaxy, because they are colliding. So there's a little bit more action there. Whether that actually provokes a supernova, I don't know. So those were taken back in 2013. Pretty cool. Just a few, 20-second exposures at exactly the same wavelength. Not quite sure why they took several. It might be because they're slightly in different places. Let's see, those two guys. in there. Let's look at the next one and see if it's moved. Doesn't look like it. So yeah, I'm not quite sure why they took all these images, but yeah, I'm sure they have a good enough reason. Yeah, see, I thought it was 40, 38, and 39. I think that's correct. Oh, there we go. So, just as a reminder, right? The bright things here are dark, and the dark things are bright. It's inverted. Which I'm not quite sure why this site displays them that way, but that's what they've sort of decided to do, at least as a default. So yeah, lots of action here. Lots of action. Pretty amazing little thing. So let's see. That was just one. Okay. Okay. So these guys and gals are looking at quite a few wavelengths, right? They're looking in the visible. They're looking in the ultraviolet. They're looking in the infrared. In the place. Let's see. Let's just take a look at the next one. So this is sort of in the ultraviolet, right? 30. Where is it? 3354. So yeah, that's sort of beyond our range. So that is definitely in the ultraviolet range there. So supposedly this is where all the high energy stuff is going on. High energy light, high frequency light, sort of implies high energies in terms of processes and whatnot. But pretty amazing, you know. These are very, very large structures. And you know, to answer your question, Bobby, about stuff in between the stars, there it is. Now, a lot of this fuzz is actually stars, right? But all this dark stuff, that is that gas and dust and plasma and who knows what else. So yeah, which of course is just obscuring our view. There's probably stuff behind this, right, that we can't see. But yeah, all this fuzz here, most of this fuzz, I would say, is actually stars. So that's a pretty nice shot. Let's see what else they got here. Okay, so that's wow. So that's a long exposure. Look at that, 5,530 seconds. I'm gonna grab my handy dandy calculator and do 5530 divided by 3600, right? Because there's 3600 seconds in an hour. So that's a 1.5 hour, a little over 1.5 hour long exposure. So this is like a full HST orbit. So, I wonder how they got that, because, you know, half the orbit is the Earth is going to be blocking your object. So they must have taken this in at least 2 orbits and added them, I guess. We'd have to look at the details. I'm just speculating here a little bit. Let's see. So that's sort of the ultraviolet view, right? Showing sort of the hottest stars, where a lot of the action is. Typically, if you look in the infrared, you'll see where a lot of like the gas and dust is. And yeah, so you can see here that there's a lot more. Ooh, that's really zoomed in. So it's showing again, the star forming regions, but you're also seeing other regions now too. That's a nice shot. And of course, you're getting full resolution too. There's no atmosphere, so this is as good as it gets. And yeah, you're putting stars on a pixel or so. Not too bad. That's what you want. Pretty nice. Pretty nice. So yeah, these are colliding galaxies. I don't remember how bright they are, but I think you can see these through a pretty decent sized scope. We'll look at the magnitudes. Now, through a telescope on the ground, like an 8-inch or a 10-inch, it's not going to look like this, right? You're going to see a little fuzzy here and a little fuzzy here, and that's it, right? You're not going to really see anything else. Maybe you'll see a little bit of a glow, maybe, but this is really, really faint, right? So this is much brighter, and this is what you see just looking through a telescope. If you took a photograph, right, a long exposure, yeah, you get something like this. So that's the infrared. Here's one smack dab in the visible. Yeah, that's pretty sweet. Some good shots. It's HST, so it's hard to go wrong with that. Probably what we should do is look at some amateur photographs of this object. I wonder if Cloudy Nights has anything like that. If anybody's posted, I'm sure they have. Let's take a quick look. So yeah, I think we're going to hang on the constellation of Corvus for a little while here. Don't know how long. I'd say at least a couple more days. Let's see if I can. Let's see. How do you search here? Do you have to? I guess I have to log in. So I thought that there was a search somewhere on here, but I might have to sign in to do that. I think I can do that without causing too much of a panic, right? Let's see if that lets me in. Yeah, it does. Ah, there's the search. Haha. So let's look for ringtail. Our club. Huh, okay. Well, let's look for 4038. Now, I think this is also called the Antennae Galaxies too. So let's take a look here. Yeah. So yeah.
Yeah, new Deep Sky Dude.
Hey there, Deep Sky Dude. Nice to see you. We're looking at the Ringtail Galaxy, taken through some amateur scopes. We were looking at HST earlier. This is a visible wavelength image. Let's see, centered on 5305 angstroms. About 1,000 second long exposure. Got that. And so I just sort of thought, we should probably take a look at some astrophotos of sort of the same thing, so you can sort of see
for like encountering with Corvus.
Yeah, in the constellation of Corvus. We're once in a while we sort of do a constellation of the day, uh, which usually extends into a few days. And what I like to do is just go through, the stars and objects and various things in these constellations. And this is the one that came up. So this is the one we are looking at. So I'm sort of seeing a big region here and a small region here. Okay, so that's probably this big and this small, right? So let's see if we can see a few things here, like this loop of stuff. Oh, I don't know. Yeah, maybe here. It's kind of hard to tell. Kind of hard to tell. There's that. Okay, yeah, kind of hard to tell exactly, but it's a great shot. I always like to look at these. You know, I don't do astrophotography, so I can't be too critical because I do greatly appreciate the huge amount of effort it takes, to do even a decent astrophoto. But I like to look at these things and see if the stars are round, which usually means that the optics are good and the tracking is good. I like to look at the edges to see if the image is not flat. And actually, these look really, diffraction spikes are going to pop up, and they're usually kind of hard to take out. It can be done, but you usually leave a lot of artifacts and whatnot. So it's best, in these kinds of situations, just to leave them because it looks cool, right? So here's a little galaxy over here too, probably in the background, right? Much smaller in apparent size, so probably behind these guys. So yeah, I think that these are actually two NGC objects, NGC 4038 and 4039. I don't know which one is which. We can probably find out. All right, well that's kind of cool. Let's see what else we got here. If you don't know about cloudy nights, check it out. It is a great place. Okay, so just a slightly different orientation, but same kind of thing. Pretty nice. So yeah, supposedly these galaxies are colliding, right? So these
there are also ARP galaxies. What's ARP?
ARP galaxies. Yeah, there was an astronomer, Halton ARP, who cataloged a lot of unusual galaxies, either strange-looking things like this, or I think there's some ARP dwarf galaxies too. So yeah, Bobby, it's just another catalog. And actually, we can look at the Simbad thing for this and actually get the ARP number. If I bet you that was Big Sky dude. Yeah. Do you know the number to that one, Deep Sky Dude? Don't remember. So pretty good. These I think were probably taken in the visible. It's really nice when they talk about what scope they used. And okay, so it was an FLI, That's Finger Lakes. Finger Lakes is an old camera company. They've been around for a long time. I used my first Finger Lakes camera about, I want to say maybe 1993, 1994 or so. So yeah, Finger Lakes has been around a while. I guess my question is the FLI Proline 16803, is that a color camera? Because this person, Aruna, isn't saying anything about filters or anything else. So what is this?
That sure got some good exposure time.
9.5 hours. Yeah. That's probably taken over several nights, probably. So
CCD camera.
16803. I think these probably are CCD cameras. Yeah. So what did I say? 16803. Let's see if we can find this one. What's the best way to find something here? Korean Proline. Was it a Proline? Yeah. So Proline. Oh, we're already here. I don't know if that's going to help or not. Sensors front illuminated, back illuminated. I don't know if we can find that one exactly. I'm not seeing an easy way. I'm not really finding an easy way to find that particular camera. So, well, we'll continue on. I'm not quite sure if this would be a color camera or not. Obviously, we're seeing this in color, but yeah, so it's kind of hard to tell. So here's another one from last April.
Yeah.
See how this looks. Oh, where are we? We got lost. Okay, so these are drawings, right? So some people actually draw what they see instead of photograph. So I think that's fantastic. So there's a little drawing. You can sort of see them here, right? So this is somebody looking through an eyepiece and drawing what they see. And actually, right, this is a positive image, right? Because the stars are white and the sky is black. So yeah, this is more in line with what you're going to see. So I don't know if you can see this all the way down here, but this is saying this is an Orion 16 millimeter. Oh, maybe a 16 millimeter focal length eyepiece. That would make sense. But I don't see anything about okay, so a 9.5 inch, actually 9.25 inch scope. So it's not too bad, for a 10-inch scope. But that is more like what you're going to see, right? You're not going to see any of these wild flying tails or anything like that. You're going to see a fuzzy gray blob. But you have to realize what you're looking at, right? And it's quite extraordinary, right? These are colliding galaxies caught in the act. All right, well, that's pretty cool. I'm looking at the time, and I'm noticing that we are running a little bit over. I I think we definitely, okay, so here's some more sketching, it looks like. Oh, that's cool. Wow. I think what they do is they draw this, you know, like with pencil or something, right? So it's black, uh, black lead or ink or paint or whatever it is, and then they take a picture of it, and then they reverse it. I think that is what they're doing here most of the time. So you see, this is with an 8-inch telescope at 285 magnification, which is really pushing it. That's a high magnification, very, very high. But, you know, under good conditions, and if you look at these objects, you know, the seeing does change. So once in a while, you know, they'll really sharpen up. And if you can remember that and draw it, then that's what you get. So that's pretty nice. That's a nice drawing. Let's see. What else? Antennae Galaxy. So this is with, supposedly with a Canon 450D. So is this some kind of a DSLR? I don't know what a Canon 450D is. We can find out. Maybe. It's pushing my potato to the limits here. Yeah. So it's a DSLR. 12.2 megapixel DSLR. So there you go. I don't know what kind of processing they did or anything. Modified and refrigerated, it says. Huh, interesting. So they cooled it down. That's a nice black background. Looks a little green though. Looks a little green. Hard to tell. But let's see, this is 4-hour exposure with a 10-inch scope. f3.9. Wow, that's a fast telescope. Pretty good though. Pretty nice. I like it. All right, I think for now I'm going to end this live stream. I'll bring you back into the real world here, at least for a little while, and wish all of you very, very well. Good evening.
And Deep Sky Dude, I checked on his channel and stuff. He's got some content. I think the latest one was from 3 days ago about the Ritlin.
Oh, cool. Yeah, Deep Sky Dude, I'm pretty sure I'm subscribed to you. I'm going to check right now. And if I'm not, I will be. But I'm pretty sure I am. I'm going to check, though, really, really quick, just to make sure. Got a slow. Yes, I'm subscribed. So, yay. Yeah. Okay. Yeah, yeah. All right. Well, like I said, I'm going to get out of here for now. So everybody have a great evening, a great day. So glad you could come in. It's always great, you know, to share this passion. And, you know, even though it's a, you know, relatively short amount of time, it's really, really great to get with all of you each and every day and just think astronomical things for a while. I think if I could do that every day, all day long, I'd be, yeah, I think that'd be really, really great. And I do that for the most part. Once in a while, though, I've got to do, you know, I've got to sleep and I've got to like drive and I have to, you know, do other things, which are all distractions to astronomy. So it's always nice to be able to come in here, sit down on the porch, here with our consumable of choice. And just chew the fat in terms of astronomy and space and science and all that kind of stuff. Fun, casual. I sort of hope it likes it. I'm just gonna keep doing what I'm doing. I'm just doing me. So I think that's pretty much as
Yeah,
much
you
as
was
I can
throwing a leg
possibly do.
down.
So all right, I'm gonna get out of here. Yeah, see, even the computer knows it's time to go. So all right, you guys, take care. I will see you in a little less than one Earth spin. All right, see you later.